In this video, we will show matrix solution for multiple power series regression using LINEST. Here we have a dataset with two independent variables, so we consider this as multiple. And we will use the power series solution, which is in the form of y equals b0 times x1 to the power b1 times x2 to the power b2. In the linear form, it will be ln y equals ln b0 plus b1 ln x1 plus b2 ln x2. And factoring out in two matrices, the first matrix will be 1 comma ln x1 comma ln x2, which is this matrix. And the second matrix will be ln b0 semicolon b1 semicolon b2, which is this matrix. This is vertical because of the semicolon. This is horizontal because of the comma. So we begin with the ln y values. So we start with ln y, array formula, ln of the y values. And the 1 comma x matrix begin with the 1 column and followed by the x column, x values, which is array formula, ln of the x values. Now that we have the ln x matrix, the 1x matrix, we can now, because it's transformed to linear form, we can now enter the LINEST formula. LINEST of data y, data x, and we'll show the full statistics. And here we have 12 outputs. We will calculate each output using the matrix operation. We begin with the Pijorina inverse, which is minverse and mult transpose of the 1x matrix and itself. And we calculate the Pijorina cofactor matrix, which is M mult transpose of this matrix and the y values, the transformed y values. Now we can calculate the coefficient, which is M mult of the Pijorina inverse and the cofactor. So you'll notice our ln b0 intercept matches to our output in the LINEST. b1 matches to the LINEST output, and b2 matches to the LINEST output. Now we can calculate for the RSS using the formula. We use mmult, multiply the 1x matrix and the coefficients. Now that we have the coefficients, we multiply it. Now we have the estimated y values. We have the y values and the estimated y values in the linear form. We can now calculate the residual sum of squares, which is sum of squares of the difference of y and y hat, or the estimated y values. 0.022444 matches to our LINEST output. Next, we calculate for the degrees of freedom, which is rows. So we calculate for the rows, the populations of the dataset range. That's 9. So our degrees of freedom will be rows minus column. Rows minus columns of the dataset range. And our degrees of freedom of the denominator will be 6. Same matches to our LINEST output. Now we can calculate for the STAX, or the standard error estimate, which is square root of the RSS, residual sum of squares, divided by the degrees of freedom of the denominator. That's STAX 0.01934 matches to our LINEST output. Now we can calculate for the standard error value of the intercept, which is equal to stay x times square root of the p-arena 1, which is 4.206 matches to our LINEST output. Next, we calculate for the standard error value of b1, which is again stay x times square root of p-arena 2, which is 0.7199 matches to our LINEST output. And we calculate for the standard error value of b2, which is again stay x times square root of p-arena 3. 1.9432 matches to our LINEST output. Next, we calculate for the regression sum of square, which is total sum of square minus residual sum of square. So we start with the total sum of square, which is equal to the population n times variance of population y of the y values, the transform y values. Now we can calculate for the regression sum of square, which is equal to TSS, total sum of squares, minus residual sum of squares. That is 1.9399 matches to our LINEST output. And the F statistics, which is equal to uh, regression sum of squares divided by the degrees of freedom of the numerator. But we have to calculate the degree of freedom of numerator, which is equal to columns of the x values. So there are two. So there are two independent variables, two values of x. So we can calculate for f statistics, which is residual sum of square divided by degrees of freedom of the numerator divided by stay x squared, this value to the power 2. And it's 25.929 matches to our LINEST output. And the r squared, this is equal to ESS, regression sum of square, divided by total sum of squares. And it's 0.896 matches to our LINEST output. This completes the matrix solution for multiple power series regression